Is decentralized finance going to replace traditional finance? Let's try to answer that question with few facts. First, most of the world's data is still in the traditional internet. 2. It is comparatively difficult and expensive to store and process data on the blockchain. And 3. Blockchains are still dealing with scaling problems. So it is quite understandable that for the DeFi ecosystem to grow, it has to depend on the data and the infrastructure available with traditional internet and traditional finance. This is where oracles come into play. Oracles act as bridges between traditional internet and blockchains. So let's talk about oracles and some of the players in the space. To understand oracles, let's start with the use cases for oracles. One primary use case for oracles is as data feeds. These data feeds can be for financial data, for fiat or crypto assets from various sources such as exchanges. These data feeds can also be for non-financial data such as weather data or sports outcome data. The data feeds are used in smart contracts relating to stablecoins, mirrored assets, DeFi lending, crypto derivatives, and asset management, etc. The second use case is proof of reserve, that is verifying off-chain reserve with financial institutions and on-chain reserve locked in smart contracts of other blockchains. This service is used in smart contracts related to digitized assets, cross-chain tokenization, and circuit breakers. Now, this leads to the fact that oracles can be used for cross-chain bridging, passing data between various blockchains. This service is used for cross-chain yield harvesting applications, cross-chain collateralized loans, and some other DeFi applications. One more use case for Oracle systems is facilitating creation of hybrid smart contracts. In case of hybrid smart contracts, part of computation takes place outside the blockchain with the help of Oracle networks. Now, blockchain oracles can be classified into two categories: centralized oracles and decentralized oracles. Centralized oracles act as a single entity that provides data from an external source to a smart contract operating with a set of security features. Such oracles are controlled by a single entity and the only provider of information for smart contracts. Centralized oracles act as traditional organizations where a single entity controls the whole system. They introduce certain problems such as bottleneck issues, single point of failure, and non-validated data. Decentralized oracles, on the other hand, do not rely on single source and single entity to process the data. Similar to distributed databases like blockchain, decentralized blockchain oracles create trustless system comprising of various nodes who are incentivized to process and verify data. We will be focusing here on two decentralized oracle systems, Chainlink and Band protocol. But first, let us understand some evaluation criteria for choosing an oracle system. The first and foremost evaluation criteria for an oracle system is data quality, obviously. Is the data fresh, validated, and is in usable format? The second criteria is how quickly and efficiently the oracle system responds to data requests. Third, oracle systems are not just about getting data from traditional internet. but also from other blockchains. So cross-chain compatibility is a primary evaluation criteria. For how many blockchains the Oracle system provides cross-chain compatibility and how efficiently cross-chain compatibility works. Now, last but not least, cost. It is another major evaluation criteria. Cost is not limited to explicit costs charged by the Oracle service provider, but should also include the implicit costs such as integration cost and technological debt introduced by the Oracle system. With that understanding, let us talk about two Oracle systems, Chainlink and Band protocol. Now let us start with Chainlink. Chainlink is the leader in the space and pioneered adoption of blockchain oracles. It was founded in 2017 and operates on the Ethereum blockchain. Chainlink uses the Ethereum-based ERC20 token, Link, to secure the Oracle network. However, Chainlink is a step ahead of Ethereum and already has proof-of-stake consensus mechanism in place. Proof-of-stake determines which nodes will validate transactions based on how many Link tokens they have staked on the network. Although Chainlink is built on Ethereum, the Chainlink Oracle networks are blockchain agnostic. As of 13th December 2021, Chainlink has secured more than $76 billion of value. Chainlink has capitalized on its first mover advantage and over the years built an ecosystem of open source community of data providers, node operators, smart contract developers, researchers, security auditors, and more. They have established key partnerships with the likes of Kyber Network, Fulcrum, Opium Network, and Synthetics. Chainlink is a decentralized Oracle network which allows blockchains to securely interact with external data feeds, events, and payment methods, providing the critical off-chain information needed by complex smart contracts. Chainlink's oracles operate as a decentralized network of nodes under centralized governance and control. Now, Link is Chainlink's native token. It is a utility token that is used for various purposes on the network: to incentivize data accuracy, to keep contracts stable, and to reward nodes for their work in validating transactions. Link is an ERC20 token that has an extra ERC223 function. This function, termed as transfer and call, facilitates transaction with smart contracts. The more Link tokens that a node holds, the more power it has within the proof-of-stake network of Chainlink. Now let us learn about the Chainlink ecosystem. The Chainlink ecosystem comprises of two types of members: node operators who provide computational resources to the network and data providers who provide data to the Chainlink networks. Chainlink node operators are the entities running the Oracle infrastructure, hardware and software that powers and secures every Oracle network running on the Chainlink network. These Oracle node operators are responsible for watching the blockchain for new incoming data requests for smart contracts, fetching the requested off-chain data from specified APIs, and delivering the data on-chain where it can be consumed by a smart contract to trigger its execution. The node operators are compensated for the computational resources they provide. Chainlink enables data providers to easily sell their data directly to all blockchains without committing any additional resources or operating any new infrastructure. One point should be mentioned here is that although Chainlink fetches data from the data providers, the data does not reach the smart contracts as is. In the case of market data per se, independent Chainlink nodes fetch market price data from various premium data providers and combine the results into an aggregated value. Then, multiple Chainlink nodes aggregate their results together off-chain to generate a tamper-resistant Oracle report, which is made available to smart contracts. Now let us talk about the use cases for Chainlink. Chainlink currently has 5 major product groups: market and data feeds, VRF, that is verifiable random function, keepers, proof of reserve services, and cross-chain bridging or CCIP solutions. Market and data feeds. Chainlink provides both financial data, which can be used in stablecoins, mirrored assets, DeFi lending, derivatives, etc., and also generalized data which can be used for NFTs, insurance applications, and predictive applications, etc. Now coming to VRF or verifiable random function. Chainlink provides this service which enables cryptographically secure randomness for NFTs and blockchain-based gaming applications. Now keepers. Keepers enable smart contracts to outsource some of the computations off-chain. Chainlink keepers enable smart contracts to automate key functions and event-driven tasks in a highly reliable, decentralized, and cost-efficient manner. Now coming to proof of reserve services. Proof of reserve services enables timely monitoring of reserve assets using automated audits based on cryptographic truth. Now last, CCIP or cross-chain bridging. Cross-chain interoperability protocol or CCIP provides a universal open standard for developers to build secure services and applications that can send messages, transfer tokens, and initiate actions across multiple blockchain networks. Now, some of the specific use cases for Chainlink are money markets, decentralized stablecoins, algorithmic stablecoins, derivatives, synthetic assets, bonds, asset management, revenue sharing, yield farming, self-paying loans, circuit breakers, NFTs, insurance, supply chain, and identity verification, etc. Now let us talk about the band protocol. Like Chainlink, the band protocol is also a blockchain agnostic decentralized oracle but is not built on Ethereum. The band protocol is built on the Cosmos network, a system of interconnected blockchains with the long-term goal of creating an internet of blockchains. Band protocol initially launched as an ERC-20 project on the Ethereum blockchain in September 2019, but transitioned to the Cosmos network in June 2020 with the release of Band Protocol 2.0. The new protocol is built on Bandchain using the Cosmos SDK. Oracle nodes on Bandchain not only relay data but also is involved in block production and validation. It gives the nodes a dual role. Bandchain uses Tendermint BFT consensus algorithm. Band protocol seems to share some strong similarities to Chainlink, yet the way they approach interoperability sets them apart. While Chainlink seems to operate across top blockchains with modular external adapters, Band's adoption of Cosmos allows it to be natively cross-blockchain network. Band token is the native token of Band's chain and is used to secure the system. Band tokens are needed to be staked as guarantee to become a Band chain node operator. Any Band token holder can delegate to validators they trust to perform their job in return for a share of query fees and block rewards. For every data request to Band chain, which requires Band tokens in the form of transaction fees, validators and their delegators earn a fee for fulfilling Oracle requests and producing blocks. This ensures that all stakeholders on the Oracle network, including data requesters, validators, and Band token holders, are economically aligned. So let's finish this by answering the question: will decentralized finance replace traditional finance? It seems that the future of DeFi is hybrid. Yes, DeFi can improve the efficiency and reach of financial services drastically. But without the infrastructure and data already available with traditional finance, there will not be many useful DeFi applications. And Oracle networks will play a major role in creating that hybrid future. With this is Sam Ghosh. Thank you very much for watching. Bye-bye.